Okay, area and perimeter, I guess this is where it starts getting difficult, but not really. Compared to the rest of the chapter, it's been pretty easy. So area and perimeter are two different things in two different dimensions. So the difference between area and perimeter is the area is the amount of space a shape takes up. So if I get a piece of paper, the amount of space that this entire thing is the area. It's in two dimensions. One dimension, two dimensions. This is two-dimensional. If you add a third dimension, that's what makes something three-dimensional, right? There's three dimensions. Well, perimeter is singular dimension. It's just like add up all the sides around the shape. That's it. I don't really like thinking or sticking to formulas for perimeter because shapes aren't really this easy anymore. You're not in grade 5, right? Shapes are composite shapes. They're shapes made up of multiple shapes. So you just have to think of whatever is on the outside of the shape, figure out those numbers, add them up, and you're done. Okay, what is a composite shape? That's what this section is about. It's a shape made up of two or more shapes. So you can see on this board, there's a bunch of composite shapes. For instance, the soccer field on the back, or the football field, whatever you want to call it, with a track that goes around it. This is a composite shape. It is a rectangle made up of also two semicircles, or one circle. To find the area and perimeter, you must first break a composite shape down into simpler shapes. We don't know the area of this shape, so I got to break it down into shapes that I know the area for, and then I can slowly start to solve. So we're going to see how that looks right now. Luckily, in this chapter, you don't need to memorize formulas. You're in grade 9, you're given all formulas, and that's on your test, on your exam, on EQAO. You're given all formulas for all shapes, right? But it's up to you to know that this is consistent of multiple shapes. So over here, I have these two pieces. That makes a circle. And then I have this piece. And I don't have to draw it. I'm just drawing it so you can see it more clearly. These are the shapes that I have, and I have to find the area of all of them. So I can label them if I want. I can go 1, 2, 3. Or I can say, well, why would I say there's two semicircles? I'm just going to say that there's one full circle. Yeah, you can just call this one circle and find the area of that circle. Sure. Okay, so now we're going to find the area. So I know that the area is going to be equal to the area of the circle plus the area of the rectangle. It's a good way to notate it. Good communication. You're saying, okay, I'm going to find the area of this circle and the area of this rectangle. Now, I don't know what the area of a circle is. Well, you can look at your formula sheet that's in your workbook. Pi r squared. Pi r squared. What's the area of a rectangle? Length times width. Okay, well, pi is 3.14. R, okay, so this is the first thing we have to do. This is the diameter, 2.4. I need to find r, which is the radius. It's always half of 2.4. So the radius, r, is always half of whatever diameter is given. And you might think, oh, this is the width of the rectangle, though. Yeah, but it's also the diameter of the circle. So I got to use a 1.2 over here. Okay, so that's the first move that I've made here. Plus, this is an easy one, length times width, 2.4 times 3.8. Now, if you want to do these separately, like area of a circle, do it, area of a rectangle, do it, add the two numbers at the end, you can do it that way too. But it's nice to have a full format when you're doing math, especially when you get to higher levels. So I'm going to go here, and I'm just going to type this into my calculator. 3.14 times 1.2 squared plus 2.4 times 3.8 equals 13.6. 13.6. I'm finding area, so I have to do meters squared. I put area on one side, I box my answer, and I'm done. Okay, don't forget your units. You will definitely lose marks if you don't put units, as you always have been. You know that I do that. Okay, let's take a look at the next question. So sometimes we add areas, right? Here I had this shape and these two shapes, so I have to add them up. Well, other times I might have to subtract. So I want to find the area of just the white triangle. I want to eliminate this piece down here. It's supposed to mimic a sail. So I got to look at these triangles, and I can find the area of the whole triangle, right? I have the height and I have the base. Okay, well, that's easy. I can say the area is going to be the area of the full triangle minus the area of this triangle. Sorry, that's supposed to be an A. So again, if I want to find the area of this white weird shape, it's not really a triangle, I have to find the full triangle, which is easy. And then I have to subtract this triangle, which is easy. This is the height of that weird looking striped triangle. That's what I said here. So I got to find the area of the large triangle is base times height divided by 2. I'm going to write that down. Okay, even though they come from different triangles, the B and the H. So I'm going to focus on the large triangle, 3.8 and 3.2. Divided by 2. And now I'm going to focus on this triangle, 0.6 and 3.2. You can jump into your calculator for if you want. I'm going to just switch it to one line. Sometimes I see answers when I do this. Okay, so I'll just tell you what I did here. I just used the 2 to get rid of one of these numbers because they're both even. So I just divided that 3.2 by 2 and I got 1.6. Then I divided that 0.6 by 2 and I got 0.3. Totally not needed. You can just jump into your calculator from here. Okay, it depends on what calculator you have. If you have an ES calculator, it's really easy to do it from there. If you don't, it might be a little tricky. Either way, try to get the answer that I'm about to get. Minus 0.3 times 3.2 equals 5.12. 5.1, what are the units? Meters squared, and this is the area. Okay, so over here we have to subtract. Now you're going to get a lot of questions where it's going to say find both, find area and perimeter. So perimeter of triangles is kind of a pain because you're going to have to probably split the triangle like this and then use Pythagorean theorem to find these slanted side lengths. Okay, that's when questions get a little difficult. You have to use Pythagorean theorem to solve for missing sides to find perimeter. So anytime you have a question where you have to find perimeter, best thing to do is look at the question and just try to label every single side that you can with numbers. So I'm going to go over here. And I know that these hash marks means that this is 3 meters as well. I know if this is 10 and this is 3 and 3, this has to be 4 in here. Okay, now I want to find out these two sides. Well, if the whole thing is 7 and this is 3, then this also has to be 4. This is also 4. So these are all the same. I can do that if I want. Okay, so I'm going to say that again. If this is 10 and this is 3 and 3, 10 minus 3 is 7, minus 3 is 4. The remainder in here has got to be 4. If this is 7 and this says it's 3, 7 minus 3 is 4, so this has to be 4, and this is the same. I'm almost done. I got this side left. That's obviously also 7. Now in perimeter, I wouldn't follow the formula on your formula sheets. Just once you label all the sides with numbers, just add them up. So perimeter is going to be 10 plus 2 7s, right? I don't have to do 7 plus 7. I'm just making up my own formula based on how many numbers I have. I have 2 3s and I have 3 4s. I'm choosing to do multiplication. Okay, I have 3 4s, 2 3s, 2 7s, and a 10. If you wanted to do this instead, I'll do it in orange. If you wanted to do that, 10 plus 7 plus 3 plus 4 plus 4 plus 4 plus 3 plus 7. Go ahead. I just went clockwise and added every single number. All right? But I know some of you are going to include that number because there's a number randomly on your page and you think you need it for perimeter, but it's not on the outside of the shape, so you don't need it for perimeter. Either way, I'm going to do this one. This is 10 plus 14 plus 6 plus 12. That's 24, 42 meters. Perimeter is not squared. So I just added them all up. You can even just sit there with a calculator. 10 plus 7 plus 3 plus 4 plus, keep it going, 42. Okay, now for area, I have to split this up into multiple shapes. So I can split this up into 1, 2, 3 shapes. Yeah, there's a lot of ways you can do this. I could have split it up into this and this, so I have a big rectangle on top and two smaller rectangles here. I could also think of the entire area as a 70. You see the whole 70? 10 times 7, the whole thing is 70. And if I can find the area of this space, which is easy, I mean, it's just 16. I can reduce it or subtract it. So there's a lot of ways to find area. Okay, I'm going to do the first way because that's probably the way you're going to see. So I'm going to say that the area is equal to the area of 1 plus the area of 2 plus the area of 3. I got to find the area of 1. 3 times 7, easy. What's the area of 2? 4 times 3, easy. And guys, it's only easy because I've labeled all these side lengths with numbers, like on the diagram. Just fill in as much as you can. Last one, 7 times 3. This is 21 plus 12 plus 21. That's 42, 54 meters squared. And that's my area. Okay. And you could have also got this by saying the whole shape minus this space in here, this shape in here. Okay, maybe some higher level guys want to do it this way. It's kind of like the reverse. So I'm going to subtract the area of 4. So all I have to do is say, well, I know the whole area is easy. 10 times 7 is 70. And the area in here is easy too. It's just 16. 4 times 4. And you get 54 meters squared. Same thing. Doesn't matter which way you do it. Just draw a bunch of numbers in your shapes. Take a step back, try to analyze, what's the least amount of work I can do here? And probably take that route. Okay, in terms of like really depending on that formula sheet, it's always a bad idea because if you're doing composite shapes, like you're not finding the perimeter of this rectangle, right? Because this piece does not exist on the outside of the shape. So it's kind of silly to follow formulas for perimeters. Okay, these are pretty easy questions. I don't think you'll have any difficulty.